The birth of the universe. Imagine a time before time existed, a moment when nothing at all filled the emptiness. There were no star, no planets, no galaxies, no light, no sound, just an infinite void of potential, a silence so complete it is beyond our imagination. And yet, within that vast emptiness, something stirred, a singular moment of infinite energy and possibility, compressed into a point smaller than anything we can fathom. Then, in an instant, everything changed. This singularity, a form of unimaginable density, exploded into existence, giving birth to space, time, energy, and matter. And this was the moment we now call the Big Bang. It marked the beginning of everything we know. The universe, vast and empty, suddenly began to stretch outward, expanding faster than the speed of light, carrying it with the building blocks of stars, planets, and galaxies yet to come. In the first fractions of second, the universe was a searing hot plasma, filled with quarks, electrons, photons, and other fundamental particles, colliding and interacting in a chaotic dance. Time itself was being created, and the laws of physics began to take shape. The universe was expanding, cooling, and beginning to organize. Within this extreme environment, the first fundamental forces, gravity, electromagnetism, and the strong and weak nuclear forces, started to guide the behavior of matter, laying the groundwork for the structure of the cosmos. As the universe cooled over the next few minutes, quarks combined to form protons and neutrons, and these protons and neutrons began to fuse into the very first atomic nuclei. Hydrogen and helium were born, and the simplest and the most abundant elements in the universe. These first elements forged into the crucible of the early universe were the seeds from which stars, planets, and eventually life itself would emerge. And in every atom of hydrogen and helium, there existed the potential for every star, every galaxy, every living creatures that would ever exist. Hundreds of thousands of years passed. The universe cooled further, allowing elements like electrons combined with atomic nuclei to form neutral atoms. For the first time, light could travel freely across space. This event, known as recombination, released what we now observe as the cosmic microwave background. The faint afterglow of the Big Bang, every telescope that gazes deep into space is essentially looking back in time, observing light that has traveled billions of years to reach us. A window into the universe infancy. Gravity, the invisible architect of the cosmos, began to sculpt the universe. Regions with slightly higher concentrations of matter attracted more matter, forming clouds of gas that collapsed under their own weight. Within these clouds, the first stars ignited, the nuclear furnaces fusing hydrogen into helium and the heavier elements, producing light and heat for the first time in cosmic history. These first stars were massive, bright, and short lived, living only a few million years before ending their lives in the spectacular My supernova. And the explosions of these stars scattered elements across space, enriching the cosmos medium with the carbon, oxygen, iron, and all the ingredients necessary for planets, oceans, and life. In this way, the death of the first stars became the birth of everything that followed. Our own solar system, Earth, and even the very atoms in our body owe their existence to these ancient stellar ancestors. We are, quite literally, children of the stars, composed of stardust and cosmic energy. And over billions of years, these processes continued. Gas clouds coalesced into the galaxies, each containing billions of stars, swirling in intricate patterns across the universe. Galaxies collided, merged, and formed clustered, creating the vast cosmic verb that stretches across unimaginable distances. Within these galaxies, successive generations of stars lived and died, producing ever heavier elements, forming planets, moons, and the complex chemical foundations for life. And now, as we gaze at the night sky, it is astonishing to realize that every point of the light we see is a star, and many are accompanied by worlds of their own. Universe is not static. It is a living, evolving entity, constantly changing and expanding. And we, on our small blue planet, orbiting a medium-sized star in the Milky Way, are privileged to witness a tiny fragment of this grand cosmic story. The story of the universe is not merely one of physics and chemistry. It is a story that evokes awe, wonder, and deep reflection. From the tiniest subatomic particles to the vast clusters of galaxies, from the first burst of light into the complex structures that host life, the universe is a symphony of creation, a testament to the extraordinary power of natural law and cosmic chance. Take a moment to reflect on this. Every atom in your body has a journey through billions of years of cosmic history. Every molecule of carbon, oxygen, nitrogen, and hydrogen was formed in the hearts of ancient stars. Every drop of water, every grain of sand, every breath you take is connected to the universe in ways that are profound and beautiful. The Big Bang was not only the beginning of matter, energy, and time, it was an invitation to explore, to wonder, to seek knowledge, and to understand our place in this magnificent cosmos. It challenges us to ask questions, to reach beyond our planet, and to contemplate the extraordinary story that led to our existence. As we conclude this journey through the birth of the universe, allow yourself to feel a connection to the cosmos. Let the enormity of space and time inspire humility, curiosity, and awe. Remember that you are a part of this story, woven into the fabric of the universe, carrying within you the history of stars, galaxies, and cosmic evolution. Take a deep breath. Imagine the universe expanding infinitely, galaxies spinning gracefully, stars igniting and dying in a brilliant burst of light. Feel the universe not as something distant and abstract, but as something intimately connected to you. You are a participant in this cosmic dance, and your very existence is a continuation of this epic story. The Big Bang was a singular, timeless moment that set everything into motion. The birth of space, time, energy, and matter. And from that single moment, the universe has grown into the astonishing, beautiful, and infinite cosmos we explore today. And in knowing this, in understanding this, we find a sense of connection, purpose, and wonder. We are stardust, we are life, and we are witnesses to the unfolding story of the universe. Earth orbits the sun. Imagine for a moment that you could step inside the boundaries of space and time and imagine rising above the earth, higher and higher, until the blue oceans and swirling clouds fade into a delicate marble suspended in blackness. Continue rising until even the orbit of the moon becomes a silver ring. Then the planets come into view, like Mercury, Venus, Earth, Mars, each one tracing its silent path around the sun. And from this vantage point, something becomes breathtakingly clear. Nothing in the universe is ever truly still. Earth, right now, is moving. It is flying through space at nearly 30 kilometers every second, fast enough to circle the Earth in less than a minute. So if it followed the curvature of our world, yet we do not feel this motion, right? We do not hear the wind of space. We do not sense the immense speed of our cosmic journey. But the truth is this: Earth is a traveler, forever following a road carved by gravity and motion. So, to understand why Earth orbits the Sun, we must go back to the beginning. 4.6 billion years ago, when the solar system was young and chaotic, a swirling disk of gas and dust surrounded a newly ignited star. Within that spinning material, countless grains collided, merged, and grew into larger bodies. Earth was among them, shaped by impacts and molten seas of rock. But from its very birth, it inherited a gift: momentum, a push, a sideways motion given it to by a spinning disk from which it arose. And this motion never disappeared. It became the basis of Earth's orbit. And to this day, an ancient momentum carries our planet forward across the vastness of space. But momentum alone is not enough to create an orbit. Something else is needed, something that pulls inward, something that holds the planets in place. That something is gravity. And you know what? Gravity is the quiet force that binds the universe together. It is the reason planets form, the reason stars ignite, the reason galaxies swirl like cosmic hurricanes. And at the center of our solar system, the sun's gravity is overwhelming. It pulls on every planet, every asteroid, every grain of dust. If gravity were the only force acting on Earth, our planet would have been dragged into the sun long ago. Earth would be nothing more than a brief flare in the sun's eternal fire. But Earth does not fall straight into the sun. Why? Because it is moving sideways. Imagine you throw a stone. If you throw it gently, it arcs to the ground. But if you throw it harder, it travels farther. But if you could throw it fast enough, the ground beneath it would curve away at the same rate as the stone falls. It would fall forever, but always miss the ground. This is precisely what Earth is doing. It is constantly falling toward the sun, but its sideways motion causes it to miss the sun every time. And so it falls endlessly, gracefully around a star. Now, this delicate balance between falling inward and moving forward is what we call an orbit. And Earth maintains this balance perfectly, not because it chooses to, but because nature has sculpted this harmony over billions of years. But Earth's orbit is not a perfect circle. It is an ellipse, slightly stretched, slightly imperfect, like a cosmic oval drawn in the emptiness of space. This means the Earth is sometimes closer to the Sun, sometimes farther away. Yet, this difference is small enough that life continues undisturbed. The seasons are not caused by the Earth's distance from the Sun, but by the tilt of its axis, a tilt that gives us winter and summer, long days and long nights. Still, the Sun's gravity remains the dominant force. It commands the orbits of all planets, each in its own lane, each with its own rhythm. Mercury races around the Sun in just 88 days, you know? Neptune drifts through the single orbit in 165 years, but Earth, with its balance of gravity and momentum, completes its journey in, 365 days a year, right? A cycle, a heartbeat of our world. Orbit shapes everything we experience: the rising and setting of the sun, the changing of seasons, the length of the year. Even the stability of our climate depends on Earth's orbit, remaining nearly constant. If our orbit were more stretched, the planet would face brutal extremes of temperature. And if Earth orbited farther out, oceans might freeze. Closer in, they might boil away. So we live quite literally in a narrow band of space where the balance of gravity and motion keeps our world warm enough to live and for life. But what keeps the Earth's orbit stable? We have to mention what prevents our planet from spiraling away into darkness or plunging into the sun's blazing heat. And the answer lies in the calm, immense harmony of the solar system. The planets tug on another with their gravity, creating slow, subtle changes over millions of years. Jupiter, the giant, influences Earth more than any other planet, but these changes are gentle. Small shift in the shape and tilt in our orbit, never enough to destroy the delicate balance that sustains us. And you know that even the sun changes over time. It loses mass slowly, casting off particles in a very steady, slow wind. And as it does, its grip on the planets weakens even so slightly, causing their orbits to expand. And millimeters each year only, almost imperceptible, but measurable. And yet, this change is so slow that Earth's orbit will remain stable longer after humanity has come and gone. But far in the future, 5 billion years from now, the sun will swell into a red giant, and its heat will grow, of course. Its outer layers will expand and expand, and the inner planets will be engulfed. And Earth may be vaporized or scorched into a barren world. Our orbit will no longer matter. The clockwork of harmony of the solar system will be rewritten. But that day lies far beyond our lifetime, right? For now, Earth's orbit continues unchanged, a stable path through the cosmos. And so, Earth circles the sun. We live out our lives unaware of the cosmic forces carrying us. Every sunrise, every season, every year is a result of this vast gravitational ballet. We are passengers on a world that falls endlessly around a star, guided by the invincible hands of physics and the ancient momentum of creation. Take a moment, feel to the truth of this. Right now, at this very instant, we're moving faster than any airplane, faster than any rocket. Yet, you feel nothing. You are traveling around the sun. The sun itself is moving around the galaxy, and the galaxy is flying through the expanding universe. You are in motion, part of a cosmic dance stretching back billions of years. Earth orbits the sun because the universe is built on motion and balance. Because gravity binds us to our star, a momentum keeps us from falling. Because the solar system was born from a spinning cloud and the spinning has never stopped. The orbit we orbit the sun because we are part of its story, a story of creation, motion, and the quiet beauty of cosmic order. So, next time when you see sunrise, remember you're not standing still. You're riding a world in flight. You are part of a celestial dance choreographed by the laws of nature. And every day, every moment, you're orbiting a star, part of an ancient journey across the galaxy. The last human colony, life beyond the solar system. What happens when the last humans leave the solar system? When the sun grows old and our worlds fade, will humanity disappear or evolve among the stars? This is a story of our possible future among distant galaxies. 5 billion years from now, our sun will expand into a red giant swallowing Mercury and Venus, maybe even Earth. Before that day comes, we must find a way to leave. It's a distant problem, but the journey must begin now. Scientists dream of generation ships, massive vessels where entire society, massive vessel. Scientists dream of generation ships, massive vessels where entire societies live, grow, and die while traveling between stars. Each ship would carry the DNA, culture, and memory of humanity. They wouldn't just move through space, they'd carry our identity. After centuries of travel, we may arrive at a new world, orbiting a calm, stable sun. It might not be Earth. After centuries of travel, we may arrive at a new world, orbiting a calm and stable sun. It might not be Earth, but it could be home, new forests, new oceans, new skies, and rebirth of a humanity story. New forests, new oceans, new skies, and a rebirth of the human story. Maybe that's the real purpose of humanity. Not to escape, but to continue, to carry the light of earth into the dark. And wherever we go among the stars, a small voice will whisper. And wherever we go among the stars, a small voice will whisper. We were born on a blue world once, and we never forgot it. When Earth becomes uninhabitable, where will humanity go? One day, our planet will no longer be the safe blue home we've always known. Rising temperatures, dying oceans, and cosmic threats remind us Earth is fragile. So, where will humanity go next? This is a story of how we might survive beyond Earth. Every 100 years, our planet grows more unstable. We've warmed the atmosphere, poisoned rivers, and stripped away forests that once gave us life. Scientists predict that within a few centuries, large parts of the Earth may become unlivable. But humanity has never been known to surrender, only to adapt. Our search for a second home begins with Mars, the planet most like our own. With frozen water, thin air, and a day similar to ours, Mars could become the first backup Earth. The projects from SpaceX and NASA aim to build sustainable habitats there within this century. Yet Mars is harsh. Freezing cold, bathed in radiation, and without a breathable atmosphere. Even if we reach it, we could even if we reach it, could we truly live there? Or would it just be a survival? Even if we Yet Mars is harsh, freezing cold, bathed Yet Mars is harsh, freezing cold, bathed in radiation, and without a breathable atmosphere. Even if we reach it, Lại câu này nữa. Yet Mars is harsh, freezing cold, bathed in radiation, and without a breathable atmosphere. Even if we reach it, we could truly live there, or would it just be survival? If Mars fails, our eyes turn to the stars beyond. Astronomers have found over 500,000 exoplanets. Nhắc lại, astronomers have found over 5,000 exoplanets, some in the habitable zone. Some in the habitable. Astronomers have found over 5,000 exoplanets, some in the habitable zone, where life might exist. Among them, Proxima b, orbiting our closest star, but it's 4 light years away. Even with our fastest technology, it would take tens of thousands of years to reach. But it's 4 light years away. But it's 4 light years away. But it's 4 light years away. Even with our fastest technology, it would take tens of thousands of years to reach. So maybe our next home isn't a planet at all, but a generation ship carrying humanity among the stars. So maybe our next home isn't a planet at all, but a generation ship carrying humanity among the stars. Perhaps we'll never find another Earth, but in our search, we may rediscover something more valuable: unity, creativity, and the courage to dream beyond limits. The stars have always watched over us. Now it's our turn to reach for them. When Earth becomes uninhabitable, where will humanity go? One day, our planet will no longer be the safe blue home we've always known. Rising temperatures, dying oceans, and cosmic threats remind us Earth is fragile. So, where will humanity go next? This is a story of how we might survive beyond Earth. Every 100 years, our planet grows more unstable. We've warmed the atmosphere, poisoned rivers, and stripped away forests that once gave us life. Scientists predict that within a few centuries, large parts of the Earth may become unlivable. But humanity has never been known to surrender, only to adapt. Our search for a second home begins with Mars, the planet most like our own. With frozen water, thin air, and a day similar to ours, Mars could become the first backup Earth. The projects from SpaceX and NASA aim to build sustainable habitats there within this century. Yet Mars is harsh, freezing cold, bathed in radiation, and without a breathable atmosphere. Even if we reach it, could we truly live there? Or would it just be a survival? Yet Mars is harsh, freezing cold, bathed in radiation, and without a breathable atmosphere. Even if we reach it. Lại câu này nữa. Yet Mars is harsh, freezing cold, bathed in radiation, and without a breathable atmosphere. Even if we reach it, we could truly live there, or would it just be survival? If Mars fails, our eyes turn to the stars beyond. Astronomers have found over 500,000 exoplanets. Nhắc lại, astronomers have found over 5,000 exoplanets, some in the habitable zone. Astronomers have found over 5,000 exoplanets, some in the habitable zone, where life might exist. Among them, Proxima b, orbiting our closest star, but it's 4 light years away. Even with our fastest technology, it would take tens of thousands of years to reach. But it's 4 light years away. But it's 4 light years away. Even with our fastest technology, it would take tens of thousands of years to reach. So maybe our next home isn't a planet at all, but a generation ship carrying humanity among the stars. So maybe our next home isn't a planet at all, but a generation ship carrying humanity among the stars. Perhaps we'll never find another Earth, but in our search, we may rediscover something more valuable: unity, creativity, and the courage to dream beyond limits. The stars have always watched over us. Now it's our turn to reach for them. What is a black hole and why can't light escape? Close your eyes for a moment. Imagine a place where the laws of physics ban, where space folds into itself, and when time slows to a crawl, a place so dense, so powerful that nothing, not planets, not stars, or not even light, can escape its grasp. You know that this place is not fantasy. It is real. It is a black hole. The story of a black hole begins long before its birth. It starts in the heart of a massive star, one so large that its weight is measured in tens times in the mass of our sun. For millions of years, this star burns with unimaginable brightness, fusing hydrogen into helium, helium into heavier elements, fighting against the force that threatens to crush it. That force is gravity. Gravity is patient, silent, relentless. As long as the star burns fuel, it pushes outward its energy, balancing gravity's inward pull. But eventually, every star runs out of fuel. And when a massive star reaches that moment, a catastrophe unfolds. The outward pressure collapses. The core shatters under its own weight, and in less than a second, the star implodes. The collapse is so violent that atoms themselves are crushed. Protons and electrons merge into neutrons, and the density climbs to levels that define imagination. And if the star is massive enough, if its core exceeds about 3 times the mass of our sun, gravity wins completely. Nothing can hold it up. Nothing can stop the fall. The core collapses into a point of infinite density, a point where the space and time themselves break. This is the birth of a black hole. But what is a black hole, really? Actually, it's not a hole, not empty space. A black hole is a region of a space where gravity is so strong that escape is impossible. Around this region lies a boundary, a one-way door, a cosmic event horizon. Cross it, and you can never return, not because something blocks your way, but because the structure of space-time itself tilts inward, like a waterfall of space, flowing faster than anything can swim upward. To understand why light cannot escape, you must think of a space not as emptiness, but as a fabric, something that can bend, twist, and curve. A black hole bends its fabric too steeply that all paths, even paths that light might take, lead inward. So light waves travel forward in time, but near a black hole, the direction of forward bends toward the center. So light, obeying the rules of physics, moves inward, not because it is pulled, but because space-time gives it no other direction to go. This is the ultimate prison, not walls, not force, geometry. So outside the event horizon, gravity weakens. Planets, stars, clouds of gas can orbit safely if they keep their distance. But approach too close and the ties of gravity becomes brutal. Objects stretch, pull, elongate, and scientists call it spaghettification, a gentle word for violent fate. The difference in gravity between your head and your feet becomes so great that it tears you apart long before you reach the center. And yet, black holes are not monsters. They are part of the universe's life cycle. When a massive star dies and forms a black hole, the explosion that accompanies it, called supernova, scatters heavy elements into space. The iron in your blood, the calcium in your bones, the gold in your jewelry, all forged in the furnace of dying stars, released into the universe by the same process that creates black holes. Black holes come in sizes that defy belief. Some are only a few kilometers wide, the remnants of a single collapsed star. Others, called supermassive black holes, sit at the centers of galaxies, millions or even billions of times the mass of the Sun. The black hole at the center of our own Milky Way, Sagittarius A, has the mass of 4 million suns, yet it is smaller than the orbit of Mercury. But how does something grow so big? Black holes feed. They swallow gas, dust, stars, even other black holes. When material spirals inward, it forms a disk hidden to extreme temperature. This disk shines brighter than entire galaxies. Yes, jets of energy can erupt from the poles, stretching across light years. So, paradoxically, some of the brightest and brightest objects in the universe are powered by the darkest ones. And yet, even with all this violence, all this power, black holes can also be quiet, silent, invisible. A black hole drifting alone through space leaves no trace unless something wanders too close. Billions may exist in our galaxy, unseen, unfelt, passing through the darkness like ghosts made of gravity. So what is lies at the center? What is lying at the center of a black hole? The truth is, no one knows. We call it singularity, a point where our understanding falls, where density becomes infinite, and the known laws of physics break down. Some theories suggest the singularity may not be a point at all. It might be a ring, a surface, a quantum scale region where space and time fluctuate widely. Others suggest that singularities do not truly exist, that black holes are windows into new physics we have yet to discover. And inside the event horizon, time itself behaves strangely. From the outside, if you watched someone fall into a black hole, you would never see them across the horizon. Time would stretch. The fall would slow, freeze, fade into darkness. But from their perspective, they would plunge inward in seconds. The universe outside would seem to accelerate. Stars would shift. Galaxies would evolve. They would fall toward the center, helpless, carried along by space-time itself. Black holes bend time. They bend the light. They bend the universe. And then comes the strangest part of all. Black holes are not eternal. Physicist Stephen Hawking discovered that black holes slowly leak energy. They glow very faintly, an invisible light known as Hawking radiation. Over unimaginable lengths of time, this radiation drains their mass. A black hole can take longer than the age of a universe to evaporate. But eventually, even the mightiest black holes will fade into nothing. Their last moment will be a burst of energy, a cosmic sigh as space-time returns to calm. So why can't light escape a black hole? The answer is simple and profound. Because light always takes the straightest possible path through the space-time, right? Near a black hole, the straightest path always lead inward. Light does not fall into a black hole because it is weak, but because space-time itself curves in such a way that a way no longer exists. Black holes are reminders that the universe is strange than our intuition. They show us that space is flexible, that time can stretch, that gravity is not just a force, but a shape. They reveal the limits of our knowledge, and beyond those limits, mystery. They are not the end of understanding, but the beginning. The next time you look at the night sky, remember, somewhere out there, hidden among the stars, are places where time slows, where space collapses, where the universe shows one of its most powerful and elegant creation. Black holes are not darkness. They are structure. They are geometry. They are the shadow of gravity at its most extreme and the gateway to the unknown. The hidden truth behind the wow signal. Did aliens trying to contact us in 1977? Have you ever heard about the mysterious signal from deep space, a signal that has left scientific community stunned and asking the big question, are aliens trying to contact us? That signal is called the wow signal, a strange radio signal discovered in 1977, becoming one of the most mysterious phenomena in history of space research. Since its discovery, the wow signal has inspired many scientists, astronomers, and space enthusiasts. But what is really behind this signal? Is an extraterrestrial civilization trying to send us a greeting? Or is it simply a natural phenomenon that is not fully understood? In today's video, we will explore the hidden truth behind the wow signal, analyze the hypothesis, and find out why this signal remains an unsolved mystery after more than 4 decades. Let's start this mysterious journey now. On August 15, 1977, while conducting the SETI project, the search for extraterrestrial intelligence at Ohio University Big Ear Observatory, astronomer Jerry R. Ehrman detected an extremely strange radio signal. The SETI project at the time focused on detecting radio signals from space, in the hope of detecting signs of extraterrestrial civilizations. The detected signal lasted exactly 72 seconds, the time Big Ear could observe a point in the sky before the Earth rotated. But what really made it special was the frequency at which the signal was emitted. In 1420 megahertz, also known as the frequency of hydrogen, the most common element in the universe. As soon as it was discovered, Jerry Ehrman noted "wow" on the data printout, and the name wow signal was born, becoming one of the greatest mysteries in astronomy. Wow signal has very different characteristics compared to other natural signals that scientists have encountered. First, the signal lasted exactly 72 seconds, the time it took Big Ear to point its antenna at a point in the sky before the Earth rotated, meaning it appeared within a very specific time and location range. The signal strength was strong and had a very clear increase and decrease over time, unlike noise signals or natural radiation sources such as waves from stars or gas clouds in space. This led many to believe that the source of the signal could come from an intelligent transmitter. Furthermore, wow signal appeared only once and was never detected again, even though scientists scanned the same area of the sky many times. This made the signal a very rare and mysterious phenomenon, causing the scientific community to ask many questions about its origin. Since the wow signal was discovered, Many hypotheses have been put forward to explain this strange phenomenon. A popular hypothesis is that the signal originated from a natural phenomenon. Some have suggested that the signal could be caused by frequency resonance from a star, planet, or gas cloud in space. However, to date, no confirmed astronomical phenomenon has been found to explain this signal, because the characteristics of the frequency, intensity, and timing of the wow signal are very special and different. Another hypothesis is that the signal could be the result of a technical error or interference from equipment from Earth or artificial satellites. Another hypothesis is that the signal could be the result of a technical error or interference from equipment on Earth or artificial satellites. However, the SETI project has tested the entire system, ruled out the possibility of common interference, and has not detected any technical problems at the time the signal appeared. The most intriguing and controversial hypothesis is that the wow signal could be the greeting or a message from an extraterrestrial civilization. The 1420 MHz frequency or hydrogen frequency is considered the universe language of space because hydrogen is the most abundant element and emits a very distinctive signal. If another civilization wanted to make contact, they could choose this frequency to be easily identified. Although attractive, the alien hypothesis is still unproven. The unique appearance of the wow signal makes it difficult to verify its origin. If it is truly an intelligent signal, why did it only appear once and not appear? If it is truly an intelligent signal, why did it only appear once and not repeat? Soon after the wow signal was discovered, many efforts were made to search for similar signals. The Big Ear Observatory scanned the area of the sky many times in the following years, but never found a signal like the wow signal. Not only Big Ear, other observatories and SETI projects around the world also focus on scanning the area of the sky where the signal was discovered. They use more modern equipment, newer technology in the hope of rediscovering or at least being able to collect more data to better understand this strange signal. However, the signal never repeated. This made it impossible for scientists to determine exactly its origin and meaning, turning the wow signal into a great mystery in the astronomy industry. However, the mystery of the wow signal did not diminish the curiosity and research motivation of the scientific community. On the contrary, it has become a source of inspiration for many new projects in the field of searching for extraterrestrial life, making people continue to look up to the vast sky, hoping that one day there will be a clear answer. So, why is the wow signal still a mystery after more than 40 years? First, it was one-off occurrence, a phenomenon that is difficult to study and confirm. The lack of additional data limits the ability to analyze and evaluate hypotheses. Furthermore, the universe is vast and complex, and radio signals can be affected by many factors such as interference, astronomical phenomena, or simply the coincidence of the natural phenomena. Nevertheless, the appearance of the wow signal still makes us wonder about the possibility of extraterrestrial civilizations and the methods they may use to communicate with us. Wow signal is not just a strange radio signal, but also a symbol of an unexpected mysteries in the vast universe out there. It is a sign of an extraterrestrial civilization trying to send us a greeting. Or is it simply a rare natural phenomenon that we do not fully understand? The answers to those questions still lie in the dark. But wow signal has certainly inspired millions of people around the world, from scientists to space enthusiasts. It reminds us that, despite all the scientific advances, the universe is still full of mysteries and unexplored things. And who knows, in the near future, with the development of technology and new exploration projects, we will have the exact answer about the origin of wow signal, a greeting from afar or a natural mystery that humans are still absorbed in learning. Thank you for joining me on this journey to discover the hidden truth behind the wow signal. You will find this video useful and interesting. Don't forget to like and subscribe so you don't miss out on other great videos. Black holes might be gateways to other universes. Here is the mind-bending truth. In this vast universe, there is one of the most terrifying, mysterious, and fascinating phenomena: black holes. There are points in space where the pull of gravity is so strong that nothing, not even light, can escape. Anything that falls into a black hole disappears, or at least that's what we used to think. But there's a theory that's even bolder, weirder, and more fascinating. What if a black hole isn't just an end, but a doorway to another universe? So in today's video, we will explore the most mind-bending theories about black holes, the concepts of the multiverse, wormholes, and why some scientists believe that each black hole could be a gateway to a new universe. And why some scientists believe that each black hole could be a gateway to new and why some scientists believe that each black hole could be a gateway to a new universe. Are you ready? Let's get started. First of all, let's get it clear. What is a black hole? A black hole is formed when a massive star collapses under its own weight after running out of fuel. The result is a region of space with an incredibly high density of matter, creating The result is a region of space with an incredibly high density of matter, creating a gravitational pull so strong that nothing can escape, not even light. The boundary around a black hole is called the event horizon, the point where if you cross it, you cannot come back. All information, all matter inside the event horizon disappears from the universe as we know it. But that's just a description at the observational level. When we delve deeper into physics, especially Einstein's theory of relativity and quantum physics, we start to see much stranger things. One of them is the hypothesis that black holes can be linked to another universe, or even create a completely new universe on the other side. Imagine you are flying towards a black hole. As you approach the event horizon, time begins to slow down for an outside observer. As you approach the event horizon, time begins to slow down for an outside observer. To you, everything seems normal, but to others, you appear to be frozen at the edge of the black hole. What happens when you cross the horizon? No one knows for sure. One of the proposed hypotheses is that the inside of a black hole is not just an end, but rather a beginning. Specifically, the beginning of another universe. So this is the idea of the multiverse, that beyond our universe, there are countless other universes that exist in parallel, each of which may have completely different laws of physics, time, and even space. According to some theoretical physicists, each black hole could create its own Big Bang inside itself, giving birth to a new universe. Just as a tree grows from a seed, each black hole is a cosmic seed. If this is true, then our universe could have begun inside a black hole in another universe. Related to this idea is another fascinating concept, the wormhole. A wormhole is a theoretical structure in space-time that connects two points that are very far apart, either in the same universe or between two different universes. Think of it like this. If space were a sheet of paper, a wormhole would be a way to fold that sheet of paper in half and punch through it, shortening the time it takes to travel. Some theories suggest that black holes and white holes. Some theories suggest that black holes and white holes, the opposite of a black hole where matter is spit out, could be two ends of a wormhole. That means that if you fall into a black hole, you could emerge somewhere else in the universe or even in a completely different universe. The problem is that we haven't found any wormholes yet, and these structures may be unstable. Current physics suggests that keeping a wormhole open requires a type of matter called exotic matter, something Current physics suggests that keeping a wormhole open requires a type of matter called exotic matter, something that has yet to be proven to exist. But in the world of theoretical physics, it remains a serious, promising line of research. One of the biggest mysteries about black hole is the problem of information. According to the basic principles of quantum physics, information is never destroyed. However, if an object such as a person, a spaceship, or even a star falls into a black hole, according to the theory of relativity, if an object However, if an object such as a person, a spaceship, or even a star falls into a black hole, according to the theory of relativity, it will be crushed and disappear. So where does its information go? It is erased from the universe, or is it stored somewhere? This issue has created a decades-long debate among famous physicists such as Stephen Hawking, Leonard Susskind, and many others. So one of the interesting hypotheses is that information does not disappear, but it encoded in the edge of even One of the interesting hypotheses is that one of the interesting hypotheses is that information does not disappear, but it is encoded at the edge of the event horizon or transferred into another universe through the black hole. If so, then each time matter falls into a black hole, it may be playing the role of building a new universe with initial conditions sent in from that information. This not only solves the physics problem, but also raises a shocking possibility. Our universe is a child of another universe, and we are living in the heart of a black hole. The reproductive universe hypothesis is not limited to science fiction. It was proposed by physicist Lee Smolin in the theory called cosmological natural selection. According to this, each black hole is the starting point of a new universe, and the universe that creates more black holes will reproduce more strongly. It's likely natural selection, only on a cosmic level. This leads to a surprising notion. Our universe may be one of the most successful universes in creating black holes, and therefore, and therefore it has many descendants. We're not and therefore it has many descendants. We're not just part of the universe, we may be a link in the cosmic family tree in an endless chain of cosmic reproduction. So, are black holes doorways to other universes? We can't say for sure, but a growing body of theoretical evidence, mathematical models, and indirect observations. We can't say for sure, but a growing body of theoretical evidence, mathematical models, and indirect observations suggest that this possibility is real. If that's true, then H black hole is no longer a dead point, but a new beginning, a gateway to the worlds we never imagined. Rather than being a single space, the universe could be an endless web of universes linked together by mysterious doorways. And who knows, maybe one day humanity itself or the artificial intelligence we create will discover those doorways. Top 8 largest extinct fish, giants that once ruled the ancient oceans. Welcome to the journey to discover giant sea creatures, the true kings of the ancient oceans. Giant extinct fish that once ruled the water world. Before the appearance of modern great white sharks and whales, millions of years ago, the sea was home to giant underwater fish. The seas were home to giant underwater monsters, which are larger than the largest fish today. Have you ever imagined the terrifying size of the sea's creature? Have you ever imagined the terrifying size of these sea creatures? Who were they, and what did they become extinct? Today, we will review the top 8 giant extinct fish, mysterious and powerful sea creatures that once ruled the ancient oceans. Prepare to be amazed by the numbers, pictures, and fascinating stories about these ancestors of the sea. Number 1. Lysippus. Lysippus is one of the largest fish that ever lived on Earth, living about 5 million years ago during the Jurassic period. Lysippus could grow to 16.2 meters long as well. Lysippus could grow to 16 to 22 meters long as a large bus. What's special is that Lysippus was not a predatory fish, but a filter feeder. Similar to humpback whales today, they use filters in their mouth to suck plankton, tiny creatures from the seawater. And millions of years ago, the ocean was full of plankton, and Lysippus was a giant filter machine to take advantage of this food source. Despite its large size, Lysippus was peaceful and rarely hunted, but their enormous size made them one of the symbols of the ancient wilderness. 2. Megalodon. 2. Megalodon. Perhaps the name Megalodon is no longer strange to many people. This is the largest shark that ever existed, with a length up to 18 meters, more than 5 times that modern white sharks. Megalodon lived about 23 to 3.6 million years ago in the Eocene period, with sharp teeth and terrible strength, it was the ultimate predator, easily attacking whales and other large sea creatures. Teeth as large as 18 centimeters discovered around the world have scientists simulate the shape and strength of the whale. The shark has made the ocean dangerous and dramatic. 3. Cephactinus. Cephactinus was a giant predatory fish. 3. Cephactinus. Cephactinus was a giant predatory fish that lived in the late Cretaceous period, about 100 million years ago. They could grow up to 6 meters long and famous for a wide mouth filled with sharp teeth. aggressive predators. This fish had a very fast swimming speed and excellent hunting ability, making it a nightmare for many other sea creatures at the time. Number 4. Dunkleosteus. Dunkleosteus was one of the most powerfully toothed and armored fishes that ever lived. Number 4. Dunkleosteus. Dunkleosteus was one of the most powerfully toothed and armored fishes that ever lived, measuring 6 to 10 meters long and living during the Devonian period, around 358 million years ago. It had no real teeth, but its jaws were equipped with razors. It had no real teeth, but its jaws were equipped with razor-sharp bone fragments that could crush any prey that came within reach. It was an apex predator at the time, with an estimated jaw force of up to 6 tons. Fossils of Dunkleosteus have been found in many places around the world, providing that it was one of the dominant sea monsters of the Devonian period. Helicoprion. 5. Helicoprion. Helicoprion is a shark with extremely special teeth, with a spinal like a chainsaw. Living about 290 million years ago, Helicoprion was about 4 to 6 meters long. These spiral teeth not only helped it tear apart its prey, but also remain a great mystery in scientific research. Because this tooth structure has never seen, this spiral teeth not only helped it tear apart its prey, but also remained a great mystery in scientific research. Because this tooth structure has never been seen in real sharks, Helicoprion is a prime example of the strange diversity of ancient sharks and shows that the prehistoric ocean was truly a place full of wonders. Number 6. Mawsonia. Mawsonia is a giant fish belonging to the group of spiny fish, which lived about 100 million years ago, reaching up to 6 to 9 meters in length. This fish was found in the regions that are now South America and Africa. Mawsonia is the largest freshwater fish ever known, with a massive body and outstanding strength. Fossil studies show that Mawsonia may have been a formidable predator. Fossil studies show that Mawsonia may have been a formidable predator in ancient freshwater environments. 7. Lysithis. In addition to its enormous size, Lysithis is also a symbol of the development of biodiversity in the Jurassic Ocean. Show that its size may have been much larger than initially estimated, up to more than 25 meters. This shows that the diversity and complexity of marine life in the past was a force not to be underestimated. 8. Scyphactinus, other version. Scyphactinus was not only a fierce predator, but also one of the fastest swimming fish of the Cretaceous period, with a long, body and outstanding strength. Some studies show that it could reach swimming speed of up to 50 kilometers per hour, making it difficult for prey to escape their pursuit. From giant filter feeding fish like Lysithis to ocean killers like Megalodon or Dunkleosteus. From giant filter feeding fish like Lysithis to ocean killers like Megalodon or Dunkleosteus. From giant filter feeding fish like Lysithis to ocean killers like Megalodon or Dunkleosteus, the ancient ocean was a world full of giant and terrifying creatures. Each of these species is a testament to the diversity. Each of these species is a testament to the diversity and overwhelming power of nature in the distant past. Each of these species is a testament to the diversity and overwhelming power of nature in the distant past. Although they are extinct, their fossils and stories will leave us in awe and wonder. Cats, snappers, snakes, creatures will not only help us